This is the second flashcard about the basic properties of magnets. Now, magnets can attract magnetic materials, so we've just used that word there, by inducing that's that one, magnetism in that material. Now this induced magnetism can be permanent or it can be temporary. Permanent, just squeeze that in there, or temporary. Temporary. Remember that magnetism is caused by, if we take a look at a magnet here, caused by millions and millions of tiny little domains, which are to do with electron spins, all pointing in the same direction. And when that happens, their little effects all add up, creating the overall effect of a magnet. So we end up with a north pole here and a south pole here. And that creates a magnetic field which we can indicate by drawing magnetic field lines which always go from the north pole to the south pole. Like so. And this is a region of space, this magnetic field, a region of space in which other materials will experience, or other magnetic materials will experience a force. Well, how does that work? Well, if we brought a magnetic material such as iron up towards this magnet, initially all of the domains in the iron are pointing in random directions. They're all scrambled up. So they don't have any overall effect. And it's not a magnet. But if you bring it close to this magnet that we've got, then the lines of force will start to interact with that material. And it'll start to line up all of these little tiny domains, these tiny magnets inside, so that they start to point towards the South Pole. Now, the lines of force from this magnet are actually going out like this, so all of these little tiny domains will start to point in the same direction. And that will mean that we create a North Pole here and a South Pole here. We have induced a magnetic effect, induced a magnet into the material. And what do you know about unlike poles? Well, we know that they will attract. So that means that we're going to have an attractive force between this iron bar, and this magnet. So that's why magnets attract other magnetic material which aren't necessarily magnets in their own right to start with. Now, when you take that iron bar away, all of the little domains will scramble up again because it's away from the magnetic field of the bar magnet, and so we'll end up in the original condition where there is no magnet induced into that iron. So all the domains are scrambled again. Now, some materials keep the domains pointing in the same direction, such as steel. If this was a steel bar, then some of the domains would keep pointing in the same direction when you took it away from the magnet, and you will have magnetized the steel bar in a permanent fashion. So not all of the domains will be pointing in the same direction, but some of them will, and that would be a permanent effect. So let's go back to the flashcard. So magnets can attract magnetic materials by inducing magnetism in them, and this can be permanent or temporary. They exert none or very little, no force, on a non magnetic material. Oh, running out of room there. Non-magnetic material. Now, some materials just don't have their electrons in the right configuration to line up when you bring them close to a magnet. So even if you brought a piece of plastic close to this magnet, then even though the lines of force from the magnet were going through, and in this case they're all going to the South Pole, of course, then this plastic doesn't have electrons in the right configuration, they don't line up, it will not become a magnet. And that's a non-magnetic material.